Hello students and welcome back to Standard 9th Mathematics Digital class. Today we will begin with the next topic from chapter 2 Real Numbers of Maths 1. So before that, let's recall few important points. If A is greater than 0, B is greater than 0. That is A and B both are positive integers. Okay, then square root of A multiplied by B is equal to square root of A multiplied by square root of B. Okay, the next is A plus B into A minus B is equal to A square minus B square. Now this identity we have done in the previous class. Okay. Now the third point is square of root of A is equal to A, or square root of A square is equal to A. Here square and square root cancels each other. Here also we can see we have square root sign and square. So they cancel each other. Okay. Now let's see an example. Now here the question is multiply root 2 by root 8 plus root 18. Okay. So here we have to open the bracket with this root 2. So let's do it. This is equal to root 2 multiplied by root 8 plus again root 2 multiplied by root 18. So which is equal to, now we know how to multiply two surds. So we can take a single radical sign or square root sign and we can multiply 2 and 8 inside the square root sign. Okay. Plus same we can do here. So square root of 2 multiplied by 18. Now let's multiply them. 2 multiplied by 8 is 16 plus 2 multiplied by 18 is 36. Now the value of square root of 16 is 4. So we'll write that 4. Root 36 is 6. So 4 plus 6 is equal to 10. This is how we can multiply a surd with another surd. Okay. Let's now define a binomial quadratic surd. Okay. So the surds of the form A root B plus minus C root D or A plus minus C root B are called binomial quadratic surd. Now binomial means a surd having two terms, and we already know what is a quadratic surd. Quadratic surd means a surd of order 2. Okay, so binomial quadratic surd. Example: 2 root 3 plus 7 root 5. Okay, this is a binomial quadratic surd as it contains two terms. Okay, also 3 plus 6 root 3. So this is again a binomial quadratic surd. Okay. Now let's see few examples. Now here root A plus root B into root A minus root B. Now to find its product we can use the identity A plus B. So we can write here using identity A plus B into A minus B equals to A square minus B square. Okay. So therefore root of A plus root B into root A minus root B is equal to, so according to this identity we'll get root A square minus root B square. Now as we know the square root and square cancels each other. So we'll get A. And here also we'll get B. Now A is a rational number. B is also a rational number. So it means this difference of two rational number will again be a rational number. Okay, let's see one more example. Root 5 plus root 3 into root 5 minus root 3. So here we can apply the same identity, that is a plus b into a minus b equals to a square minus b square. So let's apply the identity here. So root 5 square minus root 3 square. Now root 5 square is 5, root 3 square is 3, which is equal to 2. Now 2 is a rational number. That means here when we have multiplied two binomial quadratic surds, we got a rational number as their product. So here root 5 plus root 3 and root 5 minus root 3 are called conjugate pair of each other. Also root 5 minus root 3 is a rationalizing factor of root 5 plus root 3. Now let's multiply root 5 plus root 3 by root 3 minus root 5. Okay, so now let's just interchange their places. Root 3 plus root 5. Now we can interchange because both are positive, so its value will not change. Okay, so now let's multiply this with root 3 minus root 5. Now here again we can apply the same identity. So let's apply. So root 3 square minus root 5 square, which is equal to 3 minus 5. And 3 minus 5 is negative 2, and negative 2 is a rational number. Okay, so here again root 5 plus root 3 and root 3 minus root 5, they are conjugate pair of each other as we got a rational number as their product. Also we can say root 3 minus root 5 is a rationalizing factor of root 5 plus root 3. So it means for root 5 plus root 3, both root 5 minus root 3 and root 3 minus root 5 are rationalizing factors. So we can say the rationalizing factor is not unique for binomial quadratic surds. Okay, we have learned that the product of conjugate pair of binomial quadratic surd is always a rational number. By using this property, the rationalization of the denominator in the form of binomial surd can be done. Now let's check how to rationalize the denominator with an example. Okay, so the question here is 1 upon root 5 plus root 3. Here the denominator is a binomial quadratic surd and we have to rationalize it. Okay, so now the conjugate pair of root 5 plus root 3 is root 5 minus root 3. So let's write conjugate pair of root 5 plus root 3 is root 5 minus root 3. Okay. Now we will multiply both numerator and denominator by the conjugate pair. Okay. So therefore 1 upon root 5 plus root 3 equals to 1 multiplied by root 5. We have to multiply by its conjugate pair. So root 5 minus root 3, and in denominator root 5 plus root 3. This is the denominator, multiply by its conjugate pair, that is root 5 minus root 3. Okay. Now 1 multiply by root 5 minus root 3 is root 5 minus root 3 upon. Now here when we multiply this conjugate pairs, what we will get? We'll get the square of the first term minus the square of the second term, which is root 3. Okay. So now this is equal to, now numerator will be as it is, root 5 minus root 3 upon. Root 5 square is 5 minus root 3 square is 3, which is equal to root 5 minus root 3 upon. So 5 minus 3 is 2. So thus the denominator is rationalized. Okay. Hope you have understood the concept of binomial quadratic surd. Thank you.